today we're going to talk about DevOps automation, and the primary audience is startups using Go, but a lot of this is generally applicable to any sort of backend development and DevOps. So we're going to start looking at not just how things work today, but also how we can improve things and what sort of next generation tools look like. So this is me. I'm Andre. I'm the founder of Encore. And before I founded Encore, I was a staff engineer at Spotify. And there I was part of a lot of different areas of the company, but doing everything from software engineering to systems design to technical strategy. And we spent a lot of time sort of figuring out how to scale not just software and scaling to hundreds of millions of users, but also how we scale productivity to a very large engineering organization. And so I want to challenge people to start to think about when it comes to a startup, what is it that you care about? What is it that startups need? And maybe what comes to mind for a lot of people is speed, right? What's really important and what characterizes a startup is being able to move fast. But clearly moving fast is not the only thing. You also need quality. And for those who know the design of everyday things, it's not very useful to build a product that you can't even hold properly. And if we translate that to software engineering, it's more about the sort of works on my machine phenomenon, where because there's so much difference between how we work locally compared to the vast complexity that is the cloud, it can be very difficult to achieve quality in a way that is actually fast with speed, right? And when it comes to security, everyone knows the importance of security, but oftentimes it's actually an afterthought where it's something you care about in the abstract, but when it impacts your work, it often takes a backseat to other things. And finally, more speed. Speed is really all of what startups are all about. And the problem is that speed is often in conflict with these other factors. We need to achieve quality, we need our product to be secure, but often quality and security come at the expense of speed. And this is really where DevOps and platform engineering come in. If you look at how most companies work, often it involves spinning up a DevOps team within the startup with the goal of sort of automating and improving how we work. So how does that work? Well, if you want to ship software at the end of the day, the way it looks is really you write code in some sort of editor, you ship it to GitHub, and from GitHub, you find a way to deploy it to the cloud. Seems easy enough, right? And this is, cloud deployment. And oftentimes that's where it stops. We think, okay, that's DevOps. But it's actually so much more than that. We also have to deal with local development. And for those of you who work with the cloud every day, oftentimes the local development environment is very, very different to the cloud environment. A lot of infrastructure that you use isn't available, or you need to sort of spin up it in a variety of ways with mocking and emulators and that sort of thing. You also have testing, both sort of automated testing inside of your code base, as well as testing environments or staging environments or things like that. And you might think it stops here, but it does not. If we talk about quality in particular, what you care about is documentation, you care about observability, you care about debugging, and all these things they're both about quality as well as speed, right? If you have a well-documented API, it both enables backend engineers to move faster because it's easier to figure out how can I consume another service's API, or exactly how does this thing work again. But it also enables front-end developers to move faster because what they can leverage in building the front end is better documented and with higher quality. And so these are things where it takes time for, in most setups to achieve a high level of documentation. It takes a lot of effort to achieve high levels of observability, and building a system that's easily understood is to enable sort of debugging and enable quality and speed takes a lot of time and energy. And that's what DevOps is all about. And so when we were thinking about this, we talked to a lot of startups and we asked them, what does your tech stack look like? How do you choose technology? And this is sort of what we hear again and again, what are the best practices for selecting tools to use? And sort of the three top things is, first of all, the tool should be easy and simple to use. It should not be a Rube Goldberg machine of complexity. And this is what a Rube Goldberg machine is. It's when you take a bunch of, simple parts and you combine them into something fairly crazy. The tool should follow the Unix philosophy. It should do one specific task and it should do it well. And this is also sort of a very common framing in software engineering and technology. And finally, the tool should not introduce interdependencies on other tools. They should be independent so that if you want to swap one of them out, you can do so and it will not dramatically impact the other tools that you have chosen to work with. And this sort of makes sense for a lot of people. And so let's look at what that means in the context of DevOps and DevOps automation. And arguably the two biggest tools that almost every startup uses at this point is Terraform, or things like Pulumi or CDK or CloudFormation. They're essentially the same thing, right? They are ways to define the infrastructure that you want in the cloud in sort of code. It's called infrastructure as code. And the second part is Kubernetes. And this is, in many ways, it's similar to Terraform. Instead of writing sort of configuration as code, you're writing YAML. And it's not just a little bit of YAML, it's a lot of YAML. This is a screenshot of all YAML for a hello world application with 3 small sort of backend services. And I actually joke, it's not all of it. It's actually just half of it. The rest didn't fit on the screen. Here's the second half. I'm not joking. This is actual hello world for Kubernetes. Yeah. Now, if we look at Terraform on the other hand, what you have here on this slide is a small snippet of building a pub/sub client in Go using GCP. And what that means is we're going to create a pub/sub client. We're going to create a topic. We're going to publish a message. And then we're going to create a subscription and receive a message. And it just fits on one slide. So this is pretty good, right? Well, this is Go code. So if we look at the Terraform code to actually provision this thing, it also doesn't look that bad, right? We're creating a GCP project. Inside that project, we create a pub/sub topic, and then we create a pub/sub subscription. And we've even gone to the sort of best practice where we create variables for all these things, which is super useful if you're trying to customize things for a testing environment later and so on. Unfortunately, the simplicity of this example is misleading. You see, the problem is this is missing a whole lot of complexity that, it looks simple at first glance, but when you actually try to create sort of a production-ready Terraform security hardened setup, there's a lot more than what you might see in a tutorial. So it's things like setting up service accounts for different services. You need to set up permissions to access these resources. You need to set up configuration like retry policies and message ordering and concurrency limits. You need to set up dead letter topics, and a dead letter topic then needs a dead letter subscription, and so on. So to actually do all of these things is dramatically more complex than what we would even fit on a slide. So let's say you do all of that and you provision all this thing, and then you want to update the Go code, because now that we have infrastructure provisioned for production, the Go code needs to know how to actually talk to it, right? Because here we've just sort of hard coded my topic and my subscription and project ID. So we need to change these and refer to the actual IDs that they have in production. So then we need to introduce configuration. And that configuration, we then need to copy, the output from Terraform into a configuration file. And then we need to take that configuration file and we need to save it. And as part of the deploy, we then need to use it. So suddenly, what looked really simple ends up with a lot of different steps and a lot of sort of boilerplate at every step of the way. So to summarize the Terraform developer experience, there's a lot of boilerplate in writing. You often don't even know what you need to set and how. So you end up doing a bunch of Googling and trying to figure out exactly what I need to set. If you want to change this on a per environment basis, for PubSub, you might not need to, but if you want to set up something more complicated, like a Kubernetes cluster or a database, you actually want different configuration for different environments, because you don't care about scalability as much for a testing environment. And then these config files that we talked about, we need to copy and paste them for different environments. And then we haven't even touched on local development, right? Where, Terraform, you can't use Terraform to provision things on your own machine, right? That's not what it's there for. It's for provisioning things in the cloud. And all of this stuff that we've looked at, it's entirely specific to GCP. If you want to use Azure or AWS or any other cloud provider, it's going to look completely different. And you're going to need to find different documentation and different tutorials. And it's all sort of very, very specific to a particular cloud. And running it locally is just a whole different world that we haven't even touched on. And like we talked about before, security is often an afterthought. In these examples, the downside with Terraform is oftentimes hardening your infrastructure with security is sort of something you need to opt into. The simple example is not secure. And that's really, really scary from trying to be security conscious. So if we go back to the slide and we look at what are the ingredients of a productive workflow, what we've solved with Terraform is really only the first part. We've solved how to do cloud deployments. And if you're a DevOps engineer, you love Terraform. If you're a backend developer, it feels like mommy isn't giving you any attention, and they're just playing with their favorite child. And this is really, really scary in terms of, how is it that we as an industry are just focusing our tool selection on, the production environment? What about everything else that we're trying to achieve in terms of a productive workflow? And so to handle everything else, typically we choose different tools. So we use Docker Compose to handle local development. For a testing environment, we also use Terraform. But as we saw, it's very complex. So what most startups do is they actually, they just mirror production. into a testing environment. And essentially what that means is you're just setting money on fire, right? Because that's incredibly costly in terms of having way over provisioned your testing environment. For documentation, you might use something like Swagger or OpenAPI. And for observability and debugging, you might use Datadog or Grafana or Sentry or anything like that. So if we look at this, is this picture really that different to a Rube Goldberg machine after all? I would argue it's exactly the same. We take 20 different tools and we combine them into a monstrosity of a workflow. And so are these best practices that good after all? The sort of insight that I had is it's not so much about tools that we should be thinking about as much as it's about workflows. Um, so the workflow and the tools that we have created, they're not simple. It's incredibly complex. And finally, these others or principles, they actively work against us. By focusing on the simplicity of individual tools, we forget about the simplicity of the workflow that we want. And that's arguably much more important than that individual tools are simple. So if we think back to what startups really care about, does this really achieve our goals? In terms of speed, absolutely not. This is a Rube Goldberg machine, and trying to ship software quickly with these 20 different tools that are all very complicated, not so much. Quality, I would argue, yes. If you look at tools like observability tools or error monitoring tools or OpenAPI, we have the tools to achieve quality. And that's important. And when it comes to security, yes and no. You can provision a secure production environment using Terraform, but it's very, very misleading in that it's very hard to be confident that what you have is secure, because the tools don't really help us. When it comes to quality, we actually have a lot of good tools that are focusing on that, observability and documentation tools and all of that. Security, you're sort of left on your own trying to figure out, have I configured all this correctly? Did I grant the service account much more permission than it should have? Am I using um, do I give people owner permissions just so that they can figure out the problem of the day? Because uh, locking down production infrastructure is so difficult. So let's take a step back and let's talk about sort of what we're here about again. We can achieve DevOps. We can even automate DevOps. It takes a lot of investment in terms of, people and time, and uh, it's really it's at the expense of speed, right? It may be automated, but it's not particularly fast. So how might we instead achieve 3 times the speed using next generation tooling as opposed to the status quo with Terraform? And I want to surface 3 different examples. If you're not familiar, we have Vercel, we have Temporal, and we have Encore. So let's start with Vercel. And you're going to sort of notice a trend or a commonality with these tools. And that is that they all focus on integration in one way or another. So Vercel, for those who don't know, it's a platform for front-end hosting. And the Vercel is also the authors of Next.js, which is the most popular or React's front-end framework. And what Vercel does is they build a lot of automation around front-end hosting. So maybe the headline feature is that every time you create a pull request, Vercel creates a preview environment for that pull request where you can see what does this website look like, did I make any mistakes, um, and so on. And it allows people to comment and sort of give feedback and all of that. They have fully automated deployments, which means that you just push to main and Vercel will take it from there. And finally, Vercel actually integrates directly with features in Next.js. So if you use sort of the Next.js image component, Vercel can actually read the source code and understand that, oh, you're actually using this image. Let me optimize that for you. Let me find the right size and automatically sort of shrink it to the necessary resolution. And beyond that, it's a lot of sort of website analytics and so on. And this means that compared to doing all this yourself, it's a radically improved developer experience that allows teams to ship much, much faster with higher quality. Next, let's look at Temporal. And Temporal, they describe themselves as a durable execution engine. So let's unpack that a little bit. And so let's imagine that what you're trying to do is you're building an order management system where you have a customer that places an order for, let's say, a book, and you need to sort of charge their payment method and ship the book. And obviously, you don't want fraud, so you're going to do some fraud checks. You're going to prepare the shipment and sort of reserve inventory. Then you're going to charge their wallet. And finally, you're going to ship. And if you just think about this in that way, the Go code on the screen looks really, really simple, right? I mean, that's really all what you're trying to do when you have like an order processing workflow. The problem is if you actually try to build this without using Temporal, it's incredibly complicated because all of these steps can fail. The fraud system might be down, the inventory system might be out of sync. Maybe there's a mismatch between what the database says the inventory is and what the humans in the warehouse say it is. Maybe you want to use different payment methods for different countries, or depending on if they use a credit card or a bank transfer, you name it. And then in terms of shipping, you have a bunch of different third parties that you use. And all of this complexity means that what you see on the screen is very far from reality. You need to build a lot more error handling into it. And typically the way you do that is you store a bunch of data, and then you need events, and then you need transitions and error handling and retries. And it's all very, very complicated when you actually try to do it in practice. And so this is what Temporal solves. So Temporal actually lets you write this code like I just showed you. And then Temporal handles all of the complexity of making that robust. And this is really, really powerful because it lets you sort of express business logic in the way that you reason about the business logic, not so much about sort of adding all of this complexity around observability and around state management and error handling. And finally, because it's so integrated, they actually provide observability where every time you execute a workflow, you get a lot of insight into what's happening. And so what Temporal offers is this illusion that you can run a function for days or years. Obviously, that's not how it actually works. The way it works under the hood is they just store everything in an event log, and then they can resume the function after the fact. They also provide a lot of error handling and retry management, just built into how Temporal works. And they provide really, really powerful observability features that really scale to very large workloads. So that's another aspect where integration really simplifies the workflow of building these types of systems. And finally, let's talk about Encore. And Encore we think of it as integrating Go code with infrastructure and really what that enables. So it's not just about infrastructure, it's also about building a really productive workflow around that. So we think back to this picture where, we have our code, we have our local environment, we have our testing environment, and we have our production environment in the cloud. The problem we have with existing tools like Terraform and Docker Compose is that all of these look different. They're implemented different ways, and actually achieving that is incredibly complicated. And that's the problem that Encore is trying to solve. So the way it works is Encore provides a Go SDK that you use when you're writing code, and then you use Encore Run to run it on your machine. And then whenever you want to deploy to the cloud or to a testing environment or a preview environment, Encore's platform completely automates that. So it's really focusing on DevOps automation. So let's sort of break it down. So there are three main parts to Encore. So there's the local development aspect that is really optimized for speed and simplicity. So I'm not going to go through all of these features, but the sort of main thing is that you can directly in your source code, you can express infrastructure and directly in Go access all this infrastructure in a type-safe way. There's a lot of sort of built-in whistles that we'll get into. Next, we have testing. And this is something that is really underappreciated if you think about traditional DevOps workflows. And Encore supports testing in two ways, both in terms of writing tests like automated tests, whether that's unit tests with mocking or integration tests, as well as things like creating test environments and preview environments. All of that is completely automated with Encore. And last, but certainly not least, there is the DevOps automation piece. And because Encore is all about declarative infrastructure, it means that when you're writing code using Encore's Go SDK, you are declaring what infrastructure you need, which means that Encore can take that description and just completely automate infrastructure provisioning. It means that you never have to write any Terraform, you never have to write any Kubernetes YAML files, and it's secure by default because Encore can automatically optimize all of the permissions and set things up in a way that's secure by default. So you never have to worry about, is this database locked down or not? So let's take a look at what that looks like. So like I said, Encore provides a Go SDK where you can declare infrastructure semantics in your application code. So for example, if you want to define an API in Encore, that's just a normal function. You never have to define sort of a router and then you have to wire all of that up. It's just a function. And what that means is if you want to make an API call, you just call this function like you would any other function. And Encore will translate that into an actual API call. If you want to define a database, same thing. You import Encore's SQL database package, and then you can, in your Go code, you can just declare, I want a database. And Encore will read this code and provision that database for you. It doesn't run the code, it just parses it. And that's really important, as we'll get into later. If you want to define a pub subtopic, same thing. You import the pub sub package, and then you call pubsub.new topic. And if you're familiar with Go, you actually specify the message type as a generic parameter. So you can see here that the user object is the message that's being sent. And that means that you actually get type safety between services when you're building a distributed system. And Encore will propagate this object between systems, which is really, really powerful from a sort of reducing boilerplate perspective. Same thing with caching, same thing with defining cron jobs, same thing for defining secrets. All of these things, they're all about defining the semantics of infrastructure. What you are not defining is, I want a Kubernetes cluster, or I want a database with 5 gigs of memory and 4 CPU cores. You're only defining the things that matter from the semantics of your application. And so what that means is that Encore can change how you provision infrastructure for different environments. So let's take a look at what that workflow looks like. So what you see here on the screen is a real world example where Encore provides what you see is an example of a billing system where you might have an API for creating an order. Same thing as we saw in the Temporal example. And here, in just normal Go code, you can define the request and the response of this API endpoint. And Encore will parse all of the source code, and then it will automatically render beautiful API documentation, completely automated, based on the source code itself. And so what this means is the documentation is never out of date, and you can just hand it to a front-end developer or another team that want to build using your API. Next, let's say that we want to call another service. So how we might do that is we import the other service and we call the function. So here you might see how you might call the get product endpoint to fetch information about a product. And it just looks like normal Go code, right? You're importing a package and you're calling a function. But what Encore reads into it is that, oh, this function that you're calling, it's actually an API. So what you're doing is you're making an API call. And Encore, when it compiles this service, translate this into an actual API call over the network. And what you see at the bottom is Encore's architecture diagram. And this automatically represents that now there's a dependency from the billing service to the product service. Similarly, if we look at PubSub, you might define an order created topic, and then you can publish from this API endpoint whenever an order is created. And Encore will automatically, when it provisions and starts up this service, it will automatically provision the appropriate infrastructure for different environments. So locally, you get NSQ. In GCP or AWS, you get the sort of native infrastructure that those cloud providers provide. And then you see at the bottom is the architecture diagram is automatically updated to support, to reflect that now we're actually publishing messages on this topic, and any subscription will receive that message. So what's so powerful about this is it never goes out of date because the source code is the thing that actually defines the behavior of the application. And finally, Encore, because it understands all of these API endpoints, provides an API explorer where you can easily call any endpoint as you're developing. And whenever you call an endpoint, Encore will automatically trace it, which means that you can dig into exactly what happened. If you've ever worked on distributed systems, you probably know the feeling that you're working on some new feature and you make an API call and it fails. And you have no idea where because you have like 5 different services that are all being called and you get back an error message, but you have no idea where it actually broke. So with Encore's built-in tracing, you can dig into exactly what went wrong and much easier find and fix the issue. And finally, if we look at the Encore cloud platform, you can easily integrate Encore with your own cloud, and then you can create any production or staging or test environment directly into your own cloud account. And then Encore will handle all of the DevOps automation straight to your own cloud. And because the source code captures all of the infrastructure that you need, it's fully automated. And because Encore is then optimizing it for the specifics of that environment, in a testing environment, you might want Cloud Run, whereas in a production environment, you might want Kubernetes. You can easily change that on a per environment basis. And Encore will automatically change the underlying infrastructure to be optimized for what you need for that environment. And if you want things like approvals for your production environment to make sure that you're not doing something you didn't intend to, you can obviously do that. And then to make any changes, it's just a matter of tweaking the scalability parameters. You can do that straight from Encore itself. So with that, if you want to try it yourself, you can just sign up on encore.dev, try out any of these features. It's free for hobby use, and you can build pretty much anything without, without leaving your editor. That's how powerful it is. And so to wrap it up, DevOps automation for startups, really think about the end-to-end workflow. It's not just about cloud infrastructure. It's about how can we achieve speed, quality, and security, and more speed. The status quo tools that we typically use, whether it's Terraform or Temporal, or Datadog or Grafana or Swagger or any one of these things, they're very single purpose focused. And so when you try to build a workflow out of them, you get a really disjointed and complex workflow when you combine them. And if we start looking at newer tools, whether it's Vercel or Temporal or Encore, the trend is really to focus more on integration. Instead of just blindly following the Unix philosophy, they focus on how can we simplify the workflow rather than providing modular building blocks. And that's really, really powerful in terms of just overall productivity. So that's where I'll stop. If anyone has any questions, then feel free to write them in chat, and Marcus will moderate, and we'll go from there. Thank you very much.
Cool. Thank you, Andre. That must have been quite a long breath we held for 40 minutes. Let's see. Yeah. So if anyone has any questions, you can put them on chat. Rami made a comment earlier around Temporal, calling out that it's in a way a function as a service framework to help you build event-driven systems, which is part of it, I guess. And then the sort of long running aspect is perhaps where they really shine and what people go to them for.
Yeah, I
And
think
now we have, go on.
Yeah, I think thinking of it as a function as a service, I think it's missing the point, as you say. It's about by providing integration, temporal really enables this illusion that a function can run for months or years. So that's much more powerful in terms of building complex business logic around. So while it's technically true that it's like, okay, we're going to run this function for you, uh, the end result is much more about by temporal integrating lots of different pieces, you get the workflow where you can be much more productive. Um, so um,
I'm
agree.
gonna stop you because we're getting a few questions. So Rami asked if Encore acts as an adapter for tracing, aka is it possible to export traces to Jaeger or other open telemetry tools?
Uh, that's something that we're shipping very soon. You can obviously still use those tools today. With Encore, it's just normal Go code. So Encore provides built-in tracing that's really, really powerful for local development and preview environments and staging and testing. Uh, and then for tools like Jaeger or Datadog in production, you can keep using those tools. Encore very happily integrates with them. Uh, and very soon we will also support just handling that integration automatically. So Encore already has integrations with both Datadog and Grafana, and we're going to extend that to sending traces very soon as well. Yes.
Cool. And then we have a question from Georgi, who asked if we have any plans to support multi-tenancy and multi-team ownership models in Encore.
Well, we already support a lot of these things. It's depends a bit on what you mean by multi-tenancy. If you have like a specific use case, happy to talk through that. We have use cases where, we have both um, you can have multiple Encore applications tied to an organization. You can have multiple teams that own different things. There's a lot of functionality that is not yet exposed in the UI, but is much more flexible under the hood. So if you have a specific use case, just reach out and we can talk through how to best support you. But most likely, it's already supported.
Excellent. And yeah, if that didn't answer your question, feel free to put another question in the chat. And we have a question from Swastik from Slack. Hey, he's asking if we have any plans on, let's see, do you plan on only supporting GCP and AWS? I guess, are we planning on supporting more clouds or other ways of deploying?
Yes.
Can you say more words?
Um, so we started with GCP and AWS because they tend to be the most popular when it comes to Go in particular. We're in the process of expanding Encore's language support, and with that, we do plan on supporting Azure. Uh, in general, we try to move very closely with what our customers need, and so if there's a particular use case where like, oh, we're using Azure, by all means, let's talk. We have an Azure integration that's about 60, 70% done, and really it's mostly waiting on customers requesting that functionality. We obviously Encore is a broad product in that it tries to simplify a lot of the workflow, and so we need to focus our energy where we actually have customers requesting that functionality. And Azure so far has been, um, because of Go as the first language, we supported not as common. We also have plans to, you can already today take any Encore application and build standalone Docker images, and then you can do whatever you want with them. So if you want to deploy them on a Raspberry Pi, you can do that. Or if you want to take them to DigitalOcean, you can do that, or whatever. We're also working towards, on-premise hosting and self-hosted Kubernetes clusters and things like that. So the long answer is yes, all of the above, but we're really trying to prioritize it based on sort of working closely with our customers. So we're getting there, but it may take some time depending on what you have in mind in particular.
Fantastic. And I can add a question that may be interesting to people. If you have ideas and feature requests, how do you ask them? Where should you put them?
So we have a Slack community that's very active. That's always a great place to start. We have a roadmap on encore.dev/roadmap, and there you can vote on things and you can comment on things. And am I missing something, Marcus?
You can also create an issue on GitHub if you like.
Yes.
All right. Oh, here's a biggie. So Josh just wrote, thanks, Andre, and a couple of questions. He's just getting familiar with Encore, and he's wondering, how opinionated is the project structure? It seems like some of the declarations, like service to API, need to be top level and can't be flexible, or Encore will struggle to understand the project. Maybe we start with that.
Yeah. It is a requirement that when you define an Encore service, the API endpoints must be defined in that package. You can build more complex services by having sub packages within the service package. But API endpoints in particular have to be defined in this top level package. You can, of course, if you have a more complex service, you can break it down, and those API endpoints can call other functionality that lives in sub packages. But the API endpoint definition has to live in the top level package. Now, since it's not clear exactly what you're referring to, I just want to be clear that you can also like services. Those packages do not need to be defined at the top level of the Git repository. They can be defined anywhere in sort of subdirectories and whatnot. So you have a lot of flexibility on sort of how you structure the folder structure in your program or in your Encore application, if that makes sense.
Excellent. If you have a follow-up, you can put it in the chat. But in the meantime, another question around databases. Concerning security and visibility, how much control would a team have over the database? Can it be changed to a DAAS, I guess, database as a service, like PlanetScale, but still be partly changed within Encore?
So if you want to use something like PlanetScale, you can certainly do that. not with Encore's built-in database support. PlanetScale is a MySQL database, whereas Encore currently provisions Postgres databases. That said, it's all Go code, so you can use whatever infrastructure you want. There's nothing stopping you from using PlanetScale. You can even combine PlanetScale with things like preview environments, where Encore sets up, and you can use webhooks to get notified when a new preview environment is created, and then you can use that to provision a new PlanetScale database or whatever. Beyond that, Encore has support for all the major cloud providers, database hostings, database services. We also have support for Neon coming very soon. It's already supported for preview environments, and it will come to all environments so that you can use Neon for that. So in terms of infrastructure that Encore automatically provisions for you, it's something that we need to integrate with from our side. But that doesn't stop you from using anything. You can use Encore's configuration to sort of define how to use PlanetScale, and then you can use Encore secrets to handle the authentication and the API tokens and so on. So yes, you can do that. But if you want Encore to manage all of the automation and so on, then you have to stick to the integrations that we have. If you have a specific integration, our infrastructure management system is very powerful and very flexible. So we're happy to talk through specific requests for particular integrations.
Perhaps you can also touch a bit on security and visibility in the context of the databases Encore does provision in AWS and GCP. What does that look like?
Yeah. By default, it's all sort of as locked down as can be. It's firewalled off. It's not exposed to the internet. Only the services that have access to the database in your source code will be granted permission to talk to the database. They all get individual service accounts, and Encore also separates the migrations, which need admin permissions to modify the database, from the runtime permissions, where typically you don't want the ability to modify the database schema. So all of that is sort of table stakes, and it's fully automated by Encore. In terms of and yeah, I mean, things like automatic backups is automatically enabled. All of these things that you would expect they're just defaults. You don't have to write the right Terraform to achieve that. In general, when Encore provisions infrastructure, you can freely modify it yourself in the cloud provider. And so what that means is, if you have specific requirements, you can have Encore provision the infrastructure, and then you can change it on your side, and Encore won't change it back. Encore will do a two-way sync between the settings that you define in your own cloud and Encore sort of configuration. So you do have a lot of control over what exactly the database setup is.
Excellent. And then a question around language support. Any future plans to support Rust?
Yes, we're working on supporting TypeScript right now, and that's coming very shortly. Basically, all of that is actually being built in Rust. So both the static analysis as well as the runtime itself is fully written in Rust, completely asynchronous Rust. So basically, all of that means that we will much easier be able to add future language support. So we're starting with TypeScript. We're going to add Python support later this year, and Rust probably sometime after that. But because the whole runtime is written in Rust, we plan over time to both support or more languages in general because Rust integrates so well with other languages, as well as move into, better support for WASM and WASI in terms of supporting basically any language that compiles down to WebAssembly. So absolutely, but it's going to take at least probably until next year before we have that in place.
Okay, and then a follow-up question around databases. What about access? Can we directly log into the provisioned Neon database? And I guess the same question for any type of database, Encore provisions.
Yes, there is Encore DB shell where you can just log into you can get a database shell to any database that Encore provisions. When you deploy to your own cloud account, you obviously have access to the database via your own cloud because you own it effectively. For Neon in particular, we haven't yet enabled so that you can deploy Neon databases to your own Neon account. But when we do enable that, then you can, of course, log in to the Neon console and view it because it's in your own Neon account. So depending on exactly what you mean, you can either already do that today or very soon.
Fantastic. Let's see. Question from Rami. Is or will on-premise be an option at some point?
Yes. A lot of the tooling we have around Kubernetes is actually sort of it's cloud agnostic in that Encore automatically supports sort of orchestrating Kubernetes deployments and all that. A lot of the complexity of Kubernetes is actually that it's presented as being sort of this perfect abstraction that you can just, if you support Kubernetes, it's portable and cloud agnostic. That's not true. How you use Kubernetes, it varies widely depending on if it's self-hosted Kubernetes on-premise or it's AWS Kubernetes, GCP Kubernetes, DigitalOcean Kubernetes, Azure Kubernetes. They are all quite different. And so we do support Kubernetes in general. We plan on supporting on-premise Kubernetes clusters. And so we've been working with some customers towards that for some time. So if you have specific use cases, just reach out and we can work together on supporting your requirements there.
That's great. Okay, everyone, last chance for your questions in before we end. And give it a minute. And I guess in the meantime, André, you can speak to the contact information on the screen. What's the best way to get in touch with you?
If you have specific questions, Encore Slack, Gopher Slack, or Twitter are all useful in terms of having a conversation. You can always shoot me an email if you are interested in that. So yeah, all of the above, basically. Whatever is your preferred communication medium.
What's your preferred medium?
Probably Slack. I like the interactivity of actually being able to have a conversation.
Fantastic. So Encore Slack then.
Yes.
All right, a couple of final questions. First, a call out from Svastik, who's thanking you for your guidance on issues. So that's nice of you. And then Josh is asking, I've been working with AWS Lambda for a couple of years, and I've been looking forward to a similar solution for Go and Rust. That being said, is there a mailing list for the language support?
Well, we have the overall Encore mailing list. You can sign up if you go to our blog. I believe it's at the bottom of that. You can, or any blog article. We have a newsletter. We send regular sort of updates there, and the progress we're doing on language support will be uh, highlighted there as well as in our Slack. We don't have a mailing list in that sense, other than the newsletter as well as our Slack community.
Fantastic. And then a follow on from Rami about on-premise. So it's on-premise as in air-gapped setups.
Yes, I mean probably the best way to do that today is using Encore's built-in sort of building standalone Docker images, and then you can take them and do whatever you want with them. We have had some requests for more sophisticated sort of automation where Encore can essentially produce a bunch of Helm charts that you can apply to a self-hosted Kubernetes cluster so that Encore doesn't have any connection to the cluster at all, and essentially the control plane is completely air gapped. So you can do that today with the Encore eject command. We are also happy to work with you on sort of providing more levels of automation where we can be more flexible in exactly where Encore's role ends and where you take over and sort of deploy it to an air-gapped cluster.
All right. So Rami says, thank you. He's going to get in touch eventually. Excellent. Any final questions? One more minute, and then we'll wrap it up for today. A quick question from Josh. Static IP, question mark. We'll give you time to add more context if you prefer.
Yeah. It really depends on the underlying infrastructure. Most sort of specific infrastructure requirements, we work very closely with our customers on all sort of feature requests. Static IP is one of these things that very simple for us to orchestrate. So yeah, just reach out and we can work with you on static IP. Exactly how it's set up depends on the cloud provider, whether we set up something like a NAT gateway or whatever. So do reach out. Should be straightforward.
Excellent. I think that's answered the question. And with that, let's wrap it up. Thanks everyone for joining. Thanks, Andre.
Thank you very much, everyone. And thank you for the great questions. Great to have some lively conversations.
Fantastic. All right. See you, everyone.
Thank you.